Hi everyone, welcome to the introductory video for the exercise 13 of the machine learning course. My name is Prakhar and I'll be the lead TA for this week. So this exercise primarily deals with using matrix factorization techniques to create recommender systems. In this specific case, we'll be recommending movies to users, or you can say that we'll be using the recommender system as a proxy to obtain the rating for an unseen user movie pair. We'll be using a well-known dataset called movie lens. We will then use two different algorithms, namely SGD and alternating least squares, to implement matrix factorization and then play with different hyperparameters to obtain the best results. Last but not the least, we'll compare our results to some established baselines. All right, so let's begin with task one. With task one, we'll learn to visualize the data as you can see in figure one. In this case, the left plot shows the ordered number of ratings for each user, while the right plot does the same for the movies. After the visualization, we create a 90-10 train test split from the data, as you can see in figure 2. The left figure shows the training data and the right figure shows the test data. In each plot, a dot is indicating a user movie pair for which we have the rating. So all the empty space that you see when these two data sets are combined together is an unseen movie user pair, and our task is to train a recommender system to obtain the ratings for these unseen user movie pairs. Moving on, uh, our second task is setting up a performance evaluation criterion. We'll use the good old root mean square error, or RMSE, to compare the ground truth ratings with the ones that are obtained by our matrix factorization model. For the next task, we set up three different baseline models. The first one is where we assign a single rating to all unseen movie user pairs. To obtain this single rating, we do an average of all the ratings for seen user movie pairs. The second baseline assigns a single rating for each user. For each user, we average all the ratings given by him to different movies and then assign the same rating, the average rating, to each unseen movie for that specific user. We, in the third case, we assign a single rating for each movie. So this is very similar to assigning a single rating for each user, but in this case, we assign uh, the movie the single we take the single rating to be the average of the ratings given by all the users to that specific movie. We then implement these baselines in the given IPython template notebook. Moving on, we'll implement the recommender system as a matrix factorization problem. So task 4 or exercise 3 deals with obtaining a step-by-step solution of the matrix factorization using SGD. So first of all, we obtain the correct gradient steps. Then we implement the stochastic gradient descent as it was described in the lecture. Here our objective function will be the RMSE as defined earlier. And then we implement SGD with a regularized cost function. In this case, you can see we are using two different regularization parameters, one on the weights of the user matrix and the other on the weights of the item matrix or the movie matrix. We then tune the regularization learning rate parameters as well as the rank of the ratings matrix in the IPython notebook and try to experimentally find the best hyperparameters to obtain the lowest training error. Also, as an optional task, you can try to speed up your code and try to avoid the computation of the matrix multiplication in every step. All right, the final task then involves solving the same problem, albeit in this case by alternating between optimizing the loss function with the item matrix W and the user matrix Z as separate set of variables, rather than optimizing the loss function with W and Z combined together to form the set of a single set of variables. So first of all, you will try to obtain the precise updates for W and Z for the ALS algorithm. Then you do the same for the regularized cost function. The cost function is the same as the one which we used in the previous task. And then we implement the ALS algorithm in the given IPython notebook. So that's all for this week's exercise. I hope that you will have fun solving the exercise and looking forward to discussing the solutions with you next week.